So I'll continue my video session for IGCSE, that is 0620, and I was doing May-June 2025. This time I've selected the variant 62. It's ATP alternative to practical. The total time is 1 hour. I'm not going to waste time in the instructions and information, as you all are aware of the instructions. You know that qualitative analysis list will be provided to you like this. So let's start with question number 1. Here's question number 1. When heated, magnesium reacts with steam to make magnesium oxide and hydrogen gas. Figure 1.1 shows the apparatus a teacher uses to react clean magnesium ribbon with steam and collect the hydrogen gas produced. So here's the setup in figure 1.1. We have water and mineral wool on the left-hand side. And in the middle, we are having clean magnesium ribbon. This need to be labeled A. Name the item of apparatus labeled A. It's gas syringe. So you write gas syringe here. B. Suggest how the magnesium ribbon should be cleaned before use. Rub with sand or abrasive paper. Part C. State the purpose of the mineral wool. Definitely it's reacting with water or steam. So mineral will be the one which is holding or absorbing the water. So you write hold or absorb water. Hold or absorb water. Part D. Draw two arrows on figure 1.1 to show the two places where the apparatus should be heated. Now they are saying magnesium reacting with steam. So we need water in the gas state. So we need to heat at this point. You need to provide heat at this point as well as to magnesium ribbon. So these will be the two arrows you are going to show. E. During the reaction, a colorless liquid collects at the point marked X on figure 1.1. Suggest the identity of liquid X. So at this point, it must be water or H2O. Water or H2O that will be collected. Water or H2O. As the steam is coming out from this mineral wool, from this point, it's reacting with magnesium, and furthermore, the other steam molecules will be condensed or cooled at this point X. F. The gas collected in A is not pure hydrogen. Suggest why the gas collected is not pure. Definitely, the tube is containing air. That's why it's not pure. So you write contains air.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring, from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
Moving to the next question. A student investigates the temperature change when anhydrous lithium chloride dissolves in water. The student does 5 experiments. Experiment 1. Use a 50 centimeter cube measuring cylinder to pour 40 centimeter cube of distilled water into a 100 centimeter cube beaker. Use a thermometer to measure the initial temperature of the water. Add a 2 gram sample of anhydrous lithium chloride to the water in the beaker. Continually stir the mixture in the beaker using thermometer. Measure the highest temperature reached by the mixture in the beaker, empty the beaker and rinse the beaker with distilled water. Repeat experiment 1 using 30 centimeter cube of distilled water instead of 40 centimeter cube. This will be experiment 2. Now experiment 3. Repeat experiment 1. This time you will use 25 centimeter cube of distilled water. In experiment 4, you will use 20 centimeter cube of distilled water. In experiment 5, we'll use 15 centimeter cube of distilled water. A. Use the information in the description of the experiments and the thermometer diagrams to complete table 2.1. So here's table 2.1. In all the experiments, they have used 2 grams of lithium chloride. So straight away, you'll write 2 in all these experiment 2, experiment 3, experiment 4, as well as experiment 5. Now for experiment 1, the highest temperature reached is 27. In order to find the temperature change, you need to subtract 22.5 from 27 minus 22.5. What you will get? You will get 4.5. For experiment 2, the highest temperature reached is 29. Subtract 22.5 from 29 and we'll get 6.5. For experiment 3, the highest temperature will be 30.5. The temperature change must be 8. For experiment number 4, the highest temperature reaches 32.5. And temperature change 10.5. For experiment 5, the highest temperature reached is 35.5. Temperature change 35.5 minus 22. You will get 13.5. I made a mistake here. It must be 22. It's not 22.5. That's why you will be getting 10.5. Complete a suitable scale on the y-axis and plot your results from experiment 1 to 5 on figure 2.1. Draw a line of best fit. So we have volume of water in centimeter cube on x-axis, and on y-axis we are having temperature change in centigrade. For your convenience, I have already drawn the graph. You will get the graph like this. You see the points? All points are plotted correctly. Plot the line on your graph in figure 2.1 to deduce the temperature change when experiment 1 is repeated with 45 centimeter cube of water instead of 40 centimeter cube of water. Show clearly on figure 2.1 how you worked out your answer, temperature change. So if you look at this for 45, you see it is temperature change is 3.5. We will write temperature change from graph highest temperature reach will be 3.5. So we'll write 3.5 for this one. D. The energy in joule given out when 2 grams of anhydrous lithium chloride is also calculated using the equation shown. Here's the equation. Calculate the energy given out when 2 grams of anhydrous lithium chloride dissolves in experiment 5. So temperature change for experiment 5. If you look at this, what is the temperature change for experiment 5? It's 13.5. So you have 13.5 multiplied by 4.2 multiplied by what will be the, what about the volume of water? The volume of water, it's 15. So you're going to write 15 here. What we will get? 13.5 multiplied by 4.2 multiplied by 15, 850.5 joule. Estimate the temperature change when experiment 1 is repeated using 4 gram of anhydrous lithium chloride instead of 2 gram. You have increased the mass, so definitely the temperature change will be twice, approximately doubled, because the mass, this time we have used the mass is twice. So you will write temperature change approximately, not exactly, approximately doubled, because mass used is twice. Twice the previously used mass. F. Explain why the results obtained would be more accurate if the beaker used in each experiment was replaced by a polystyrene cup. Polystyrene is an insulator, so therefore prevent heat loss to the surrounding. Polystyrene is an insulator. Therefore, it prevent heat loss to the surrounding. G1. Explain why using a burette instead of measuring cylinder is an improvement. Burettes have higher accuracy than measuring cylinders. Therefore, it's an improvement. Number 2, explain why standing the beaker in water bath is not an improvement. Because the water bath keeps temperature constant. Keeps temperature constant. Number 3, a student tests two solids, solid J and solid K. Tests on solid J. Solid J is iron 2 iodide. Now they already gave us the name of the solid. The student dissolves solid J in water to form solution J. Solution J is divided into 4 portions. A to the first portion of solution J, the student adds aqueous sodium hydroxide dropwise and then in excess. Observations when added dropwise, observations when added in excess. Now it must be having Fe plus 2 ion, that is the cation. You will look for the test of this cation in the qualitative analysis. This, if you look at the list, where is this Fe2 plus? Here is Fe2 plus. So Fe2 plus, it will give green precipitate, which is insoluble in excess. So you're going to write green precipitate. And in excess, insoluble. B, to the second portion of solution J, the student adds 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous barium nitrate. Now, if you look at the list, this must be the test of the anion sulfate. Here's a sulfate ion. This will involve the test by adding dilute nitric acid, then add aqueous barium nitrate. It will give white precipitate if sulfate ion is present. And we see that the compound is iron 2 iodide, so it does not have sulfate ion. So in the observation, what you're going to write? You write no change. C, to the third portion of solution J, the student adds 1 centimeter cube of dilute nitric acid, followed by a few drops of aqueous silver nitrate. Observations. This must be the test for the anions. If you see, here's the anion list and the test. Acidify with dilute nitric acid, then add aqueous silver nitrate for all of these three. And we have iodide here, so you will be getting yellow precipitate. So you write yellow precipitate due to the presence of this iodide ion. D, to the fourth portion of solution J, the student adds 1 centimeter cube of aqueous chlorine. So what will happen if aqueous chlorine will be added to this? You see, it's iron 2 iodide. Iron 2 iodide. And we are adding chlorine. Both chlorine and iodine belongs to group 7. You know group 7? You need to learn first 20 elements. We have fluorine, chlorine, bromine, iodine, astatine, tennessine. The last two for your knowledge only. And what is the reactivity trend? The halogen, these are the halogens. Halogens above will be are more reactive. That's why they can displace the halogens below them from their compound. So chlorine is above iodine. So chlorine will displace iodine. And the product will be iron 2 chloride and iron 2 chloride and iodine. You see, iodine is displaced. So the color of the solution will become due to the formation of this iodine. So it will turn to brown. So we'll write solution turns brown. Solution turns brown. Test on solid K. Table 3.1 shows the test and the student's observations for solid K. So flame test on solid K, it gives lilac colored flame. Test to the remaining solid K is dissolved in water to form solution K. Solution K is divided into two portions. To the first portion of solution K in a boiling tube, add 1 centimeter cube aqueous sodium hydroxide, warm the product and hold damp red litmus paper at the mouth of the boiling tube. The damp red litmus paper remains wet. Test 3. To the second portion of solution K in a boiling tube, add about 1 centimeter cube of aqueous sodium hydroxide and a piece of aluminum foil. Warm the mixture and test any gas given off. Effervescence is seen. Damp red litmus paper turns blue. E. State the conclusion about solid K that can be made from observations test 2. So for this test, they have added sodium hydroxide and boil it. And you can see they have written that red litmus paper remains red. If you go to the list, here's the list of the cations. So here's the list of the cations. There's a test for the ammonium ion. On warming, ammonia will be produced. Ammonia produced will give the test red litmus test positive. So this is a test for the gas, ammonia gas. It will definitely turn red to blue. So it means that ammonium ion is absent. So what I'm going to write, I will write ammonium ion ammonium ion. You can even write the formula if you want. NH4 positive. Absent. Part F. Identify the gas given off in test 3. In test 3, they have added aqueous sodium hydroxide and a piece of aluminum foil. Form the mixture and test any gas given off. This will be the test for the nitrate ion. If you look at the test of nitrate ion, here's a test of nitrate ion. Here's a test. Add aqueous sodium hydroxide, then aluminum foil, warm carefully. Ammonia produced. So this must be the ammonia gas produced here. As you can see, they have also written the damp red litmus paper turning to blue. So it must be ammonia. So I'm going to write NH3 or ammonia. G, identity solid, identify solid K. So if you look at the details, so far from here, we have nitrate ion, NO3, NH4 absent. This one is present. What about lilac color flame? If you look at the color, flame test color, lilac color. So lilac color is for potassium ion. So it must be having K plus ion. So you're going to write K plus and NO3 minus. K plus and NO3 minus. Or you can even write or name. That will be potassium nitrate. Last question. Magnesium sulfate is a salt. Magnesium sulfate is insoluble in water. The solubility of a salt in the mass of the salt in gram that dissolves in 100 centimeter cube of water at a specified temperature. Plan an investigation to determine the solubility of magnesium sulfate in water at 50 degrees centigrade. Your plan must include how the solubility of magnesium sulfate in gram per 100 centimeter cube of water can be found. You're provided with solid magnesium sulfate, distilled water, and common laboratory apparatus. The total mark for this question is 6. And they are not asking us to draw the diagram, but you can gain mark by mentioning the name of the containers used here. So how we are going to perform this? First of all, you need to measure 100 centimeter cube of distilled water because we are doing this in 100 centimeter cube of water. So you will get marks for this and mention the name of the container. For example, beaker. Then they said that it must be at 50 degrees centigrade. So you need to heat the water to 50 degrees centigrade. Then you have to mention maintaining the temperature of water. For heating the water and maintaining the temperature, you can also write the name of the apparatus used to check the temperature, that is thermometer. Then you are going to write magnesium sulfate. It should be added in excess until no more solid dissolves. Then you can gain more point by writing that mixture is stirred or mixed. In the end, solution is filtered to remove undissolved magnesium sulfate so that we will know the mass used, then measure the mass that dissolves using balance. So you can write any 6 from these, any 6 from. Measure 100 centimeter cube of distilled water. You can write using measuring cylinder and take in a container. Name the container, beaker. Second point, heat the water. Heat the water to 50 degrees centigrade using Bunsen burner. Then we have to maintain the temperature of water. Maintain the temperature of water using thermometer. Then add magnesium sulfate. Magnesium sulfate is added in excess. Until no more solid dissolve. Then mix the solution. The solution is stirred or mixed. What else you are going to do? Then solution is filtered. Solution is filtered to remove undissolved magnesium sulfate. Or the mass used is known. What else you can write? Measure the mass that dissolves using balance. Measure the mass that dissolves using balance. So you can write any 6 from these in order to gain full 6 marks. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.